Okay, this is section 4.4, Advanced Algebra 2 Trig continued, and we're talking about composite functions, okay? So, I want to present the idea. There's 5 boxes here. I want to present the idea, right? So the idea is, if you start with a domain value, say of x, right? And you take that domain value and you plug it into the g function, okay? Then you would expect g of x to come out. Then, if you take g of x and plug it into the f function, you would get the composite f of g of x. So here's an example, right? So let's say we say x is equal to, let's say x is equal to 1, okay? If x is equal to 1, I plug it into the g of x function. Let's say the g of x function happens to be x plus 1. So if x is equal to 1, I plug it into the g function. Well, 1 plus 1 is 2, so out would pop a 2. Then I would take the 2 and I would plug it into the f function. So 2 plus 3 is 5. So the composite function would be a value of 5. So f of g of x would be 5. So this is the idea. This is what we're doing with this stuff here, okay? So let me show you how to read it, okay? How to read a composite function. When you have f of g of x, okay, we read this as f of g of x, okay? The g of x is on the inside of the f of x function, and you work from the inside out, okay? All of this stuff can be written as f of g of x. It's not actually fog of x, so it looks like it. It looks like fog of x, but that's not really what it is. It's f of g of x, right? And that's the same thing as f of g of x. These two things are the two types of notation that we use to say these things. Now, you could also say this, right? Well, g of f of x, you just reverse them. That means that f of x is inside of g of x, which can be written as g of f of x. And notice that this is not the same thing as g times f of x. This is multiplication. This is function composition. Okay? All right, so now that we have the setup, we can actually use these things. Okay, so let's go over here. So here's the third box for you. I've got two functions defined, right? I have f of x is 2x squared minus 3, and I have g of x is 5x. So two basic polynomials. We're going to practice with these things, right? It's asking me to find f of g of 1. So what does that mean? Okay, so what that means is, since g of 1 is on the inside, I need to figure out what is g of 1. Well, g of 1 would be taking 1 and plugging it into g, so that gives me 5 times the value of 1, which of course is 5. Now, I take my 5 and I plug that into my f function, so I'm figuring out what is f of 5. So in this case, I take that and I plug it into the f function, which would be 2 times the quantity 5 squared, and then subtract 3. Well, that's 25. 25 times 2 is 50. 50 minus 3 is 47. So I'm getting an answer of 47, right? So let's ask the calculator here. And the calculator is upset it with me. So let's try that again. There we go, 47. So they got the same thing that we did, okay? Let's practice with these a little bit more. Okay, let's do g of f of 1. Let's take the reverse of this, right? Okay, so the first thing we're doing, since f of 1 is on the inside of my composite function, let's figure out f of 1. Well, that's going to be 2 times 1 squared and then minus 3. I'm just getting that from up here, right? My defined function of f of x. So I plug that in. Okay, that's going to give me 1 squared is 1 times 2 is 2. 2 minus 3 is negative 1. Great. Then I take negative 1 and I plug that into the g function. So g of negative 1 is equal to 5 times negative 1. And again, I'm just getting that from up here that I defined g of x. So that looks like a value of 5 times 1 is negative 5. So for me, g of f of negative 1 is negative 5. Let's just check that to make sure. And oh my gosh, they got the same thing we did. Okay, let's try this one. What is f of negative 3? Well, since f of negative 3 is on the inside, I better figure that part out first. F of negative 3, that's just going to be 2 times negative 3 squared and then minus 3, which is 9 times 2 is 18. 18 minus 3 is 15. Okay, good. Now I take the 15 and I plug it right back into f again. So figure out what is f of 15. Well, that's going to be, again, 2 times 15 squared minus 3, which 15 squared is 225. Double that is 450 take away 3 is 447. So, is that right? Let's see. According to this, yes, 447. And then we can do the same thing for g of negative 1. You should try it on your own and come up with an answer of negative 25. Okay, let's move on to the domain of a composite function. This is where things get a little weird. Okay, I've got two functions here, right? I have f of x and I have g of x. F of x is 1 divided by x plus 2. G of x is 4 divided by x minus 1. So both of these are rational functions, so I have to be careful to never divide by 0. And I'm trying to figure out the domain for the composite function f of g of x. Well, first, let's figure out the domain for f of x. And many of you have already done that, right? If I take a look at the bottom here, it's going to be all real numbers x such that x does not equal negative 2. Okay, I can't have that one because I plug negative 2 in, I get something, I divide by 0. And in fact, if I ask the calculator, hey calculator, what is f of negative 2? Notice it's going to spit back, hey, undefined, no good. So we have found the domain. Okay, good. Now let's figure out the domain for g of x, right? The domain for g of x, maybe you can kind of already see it, is going to be what value gives me a 0 in the denominator. So that's going to give me, I want all real numbers x such that x does not equal 1, because 1 minus 1 is 0. Okay, so just to check that, I can double check with the calculator. Hey calculator, what is g of 1? And again, the calculator says, hey, dude, that's no good. You don't know what you're talking about. Okay, so here's the deal, right? We're going to plug, this is f of g of x. So that means that g of x is inside of f of x. So what I'm going to do is I'm going to set up my domain for f of g of x, which is the same thing as f of g of x. So I know, I'll do that over here. So I know that my domain is going to be all real numbers x such that x is not equal to something. And I just need to figure out what those somethings are, right? Well, since g of x is already inside f of x, I cannot allow a 1 into my domain. So right off the bat, I know one of the answers is 1. So I have to just figure out what the other one is, okay? So because 1 is not allowed in the domain for g of x, I cannot figure out the domain. I cannot let it go through and become something and give me one. So I'm blocked right away. Then you got to ask yourself, okay, what are we trying to prevent? We are trying to prevent g of x from ever equaling negative 2, right? Because we cannot allow numbers that go through g of x that pop out to become negative 2 and then are run through f of x. So the way that we do that is we just set g of x, which in this case happens to be 4 over x minus 1, equal to negative 2. So we're going to set 4 over x minus 1 equal to negative 2, and this will give us that value of x that we should not allow in our function to begin with. So doing a little bit of algebra, we get 4 equals negative 2 times x minus 1, so 4 must be negative 2x plus 2. Subtracting 2 is equal to negative 2x. Okay, so now x must be negative 1. So that's the other answer I'm not allowed to have in my domain for my composite function. And what we're going to do now is we're going to check those things, okay? So right now, what is f of g of 1? So according to my composite function, I'm not allowed to have. Okay, so let's go ahead. So now we know g of 1 is no good. So let's figure out, let's see here, what is f of g of negative 1? Did we figure this out? Is this correct? Well, again, we get an undefined, right? We're not allowed to plug negative 1 into our composite function because when we plug negative 1 into g of x, it becomes a negative 2, which we cannot plug into f of x. So we have to prevent that from ever happening. But just something that's interesting here, right? When we first started this, we figured out that f of negative 2 is undefined. But when it becomes a composite function, f of negative 2, or excuse me, f of g of negative 2 is actually allowed. And that reason is because negative 2 goes through G first, becomes something other than the negative 2, and then goes into F. Okay? All right, we'll do one more example, and that'll be it. So here we go. We've got f of x equals 3 over x minus 1. G of x is 2 over x. So let's see here. The domain for f of x is going to be all real numbers x such that x is not equal to 1. And then the domain for g of x is going to be all real numbers x such that x is not equal to 0 because you can't divide by 0 over there. Okay. And it's asking me what's the domain of f of g of x. So I'll write that over here in purple. Yikes. Look out. F of g of x, right? It's going to be domain. It's going to be all real numbers x such that x is not equal to, okay? Well, right away, since g of x is inside f, I'm not allowed to have 0, so I can't plug 0 into that. Now, I want to prevent g of x from ever equaling a 1. So you set g of x, which is 2 divided by x, you set that equal to 1. And you solve this little tiny equation. Well, that's just pretty simple, right? So x is equal to 2. So that means that I cannot have 0 or 2 in my composite function for my domain. And let's check that. So what is f of g of 0? I should get undefined, and I did. Awesome. What is f of g of 2? And I also get undefined. But notice, right, I am allowed to have f of g of 1, right? The original problem. I'm allowed to have that because f of g of 1 goes through g of x first, pops out, then goes through f, so I am allowed. So therefore, the two answers that I'm looking for were 0 and 2, which I have written down there. Okay, good luck.